Yes, welcome. So now integrating between boundaries R and KR with respect to the R. Now we have pi arrow d this all over this, just the same thing like we had before. But because we are integrating with respect to the R, whenever you integrate something like a to power n, what you have is a to power n plus 1 all over m plus 1. So when we have r to power 2, what we have is r to power 2 plus 1, 3 all over 3. So when we differentiated the r that we had, we now have r squared over 2. When you differentiated the r squared, we have r3 over 3, 2. Then plus, when we differentiated the r, we also have here, we have r squared over 2. So that's how we did to get this like this. So now, taking in the boundary values, taking all the boundary values, anywhere you see r, replace it with big R, you get it. Then subtract anywhere you see r, replace with kr. So that's what we have here. So anywhere we see r, now we replace with big R. This small r we replace with big R. So when we cancel out, we have r squared here. In place of this r, we replace with big R. In place of this one, we replace with big R. So that when you have big R here, it becomes big R squared. So when you're done, you have to do the same thing for this expression. Anywhere you see small r, replace with kr. That's how we got this. So when you have this now, what else do? You simplify by bringing out r squared. There is r squared everywhere. So when you take out this r squared here, instead of having only r here, you have r3. So now you have only once r squared is taken out here, you now have only 1 over 2. This r squared is taken out because it's factored out here. You have 1 over 3. The same thing. So that's how you took out r squared in all of them. So you have this. Now, factoring out 6. When you put this 6 under here, you have 1. 3 divided by 3 is 1. 3 divided by 6 half. So you get back this expression. So what we did was that we just say 6 times everything in here. 6 times this will give you this. 6 times this will give you this. 6 times this will give you this. So you now put that 6 out here as if you're dividing through by 6 to get back this expression. So you took out 6. So you are now having only this. So when you collect like terms, you will see that here now you have 3 minus 2, which is 1. You have 3k minus 3k. So you pick all the like terms, all the to power 3 together. So when you pick all the like terms, you are now going to have minus k 3 to power 3 plus k squared minus 3k plus 1. So this is what you now have. And finally you have this. Why you have this is that this is exactly the same thing as this. But this expression is the same thing as 1 minus k cubed. So this expression is the same as this. So that is how you got from here to here. That is how you do the solution. Very, very important. Before I close, I'm going to write out these other expressions that we differentiated. So from the last place I integrated with this under the boundary R and KR to get this. Please take note. Take note of the steps. All the things I wrote on top before the steps are actually the things you do once you do it. From the last step that we got, we integrated, and I told us that whenever you're integrating with respect to the R and you're having R inside, simply means anywhere you see your R, anything that is up there, add 1 and divide it by what you have. So like here that we had R from the upper equation, we now have 1 plus 1 all over 1 plus 1. So that we have r squared over 2. That's how we got this. Here we had small letter r over big letter R. So if in over small letter r squared over big letter R. So if you integrate this second one, we are going to be having plus 1 here. And we're going to be having 3 here. So we have r3 all over 3r. That's how we got this. The same thing we'll do to this one. Here we had kr. So when you integrate, it's going to be 1 plus 1, 2 all over 2. That's how we got this. So this one, we had what? we had only KR. So when you differentiate a constant, you just add up another R. So that's how we got this from the former differentiation, from the former thing that was there. So before we got to this step, we had pi R P all over mu E epsilon into bracket or integral of, we had here R minus R squared over big R plus KR minus K big R. So this is what we had, and we are differentiating with respect to the R. So this is what gave us this. Why? Because we integrated this. This will give us R to the power squared over 2, and that is this. Integrate this one, it will give you R3 all over 3R. That is this. Integrate this one, it will give you. Integrate this one, it will give you K R squared all over 2 minus integrate this one, it will give you K R. So that's how we got this. Then from here we got this one by simply everywhere we see R, we replace with this R. We state the equation the same way like this. Then we repeat it minus anywhere we see small r, we replace with this one. So when you open this bracket up, you have this, and you take out all your, because there is r squared in all of them, take r squared out so that you have r to the power 3. So that this one will be remaining 1 over 2. This one will be remaining 1 over 3. Just like that for all of them. So now 6 is a common factor for all of them. So you take out 6 down. When you take out 6 down, you now do as if you multiplied everything up here by 6 so that you have this expression. So once you have this expression, 6 is already here. If you open up this bracket again by taking this 6 in, you get this back. So this is what you have. And because you have this, take out, because you have this, you can now have this one simply by collecting like terms. Once you collect like terms, you have this. So you have this and this. And when you concise this one, you get this one. So that is how you come about this. If you have any further questions, drop it on the comment section. Thank you. Like and share our videos.